Okay, it's on. All right, so how'd you guys feel about number one, or part one? It was mostly definitions,
Yeah,
basically.
yeah, more definitions. I'm still having a hard time between the central limit theorem and the large law of large numbers because the wording is so similar. But
Yeah.
I'll get it.
Well,
In the video, I was too, but in the video, they said, let's see, if you go watch the video, where to go? There's a little part about it that explains it, like just kind of really simplifies it. And he said the law of large numbers is much more it's accurate. Like it comes down to accuracy, kind of. That's what it means. And then the central limit theorem is all possible sample means becomes approximately normal. So
Okay.
I think the law of large numbers is just more accurate
Okay.
right off the bat, rather than central limit theorem. You have to have, but I don't know. What did you think?
that's the same.
I remember him. Oh, sorry. I remember him talking about accuracy, but then I couldn't remember which one it applied to.
Yeah.
Accuracy, because I didn't take a whole lot of notes when he was talking.
Oh, got it. That's the law of large numbers is accurate.
Okay.
But I think it will hopefully become more clear as we do more of them and compare them. But
Okay.
Well, yeah. For me, it was the what it came down to is the law of large numbers was accuracy. It was just that was accurate. That was its whole goal. Is that it was regardless of whether it was normal or not, it was more whatever your solution, whatever you came up with, it was more accurate.
Okay.
Whereas the central theorem is as the number of samples, or as the number of the number of data, basically the number of what you get, as that gets higher, the closer to the normal it gets.
Okay.
yeah, that's how I understood it too.
All right.
All right. So we were supposed to either cut out or do the random sampling thing, the app or the website thing. Did you guys? I just did a sample thing on the app, on the website.
And I cut out the squares.
And she cut out the squares.
But
So
how are we going to do this together if we have
hi.
because they said select 5 random and compute the sample mean, but and then it's for a group preparation session. So if we all got different numbers, then what?
Well, we were supposed to pull numbers and just kind of, because we weren't supposed to say don't do it until you do your group presentation, do your group session. But it says just to prep them.
Okay.
So, and yeah, our answers are all going to be different, but they should all be pretty close. Our mean sample should be pretty close.
Yeah, well, it says together to select 5, so we're supposed to do that together.
Oh.
That's 7. It says select 5 of the 30 salaries. Do you want to? We can just do that random app or that random.org thing, that random integer generator.
Carolyn has the little squares right there. She can just grab 5 right now too.
Okay. I'll grab the 5.
But that
Okay,
random
cool.
integer thing would be cool too. But
Well, I just ran it. It gave me 5 numbers at random.
Oh, okay. All right. You got it then? Okay.
Yeah. I mean, it doesn't matter. You can pulled up. It pulled up. Oh, hold on. Now it's rebooting. It's got 16, 25, 10, 6, and 25 again, so I have to do a second one. So 16, 25, 10, 6, and 22.
Oh, you're going to have to tell me what they are because mine are all cut up.
Okay.
And I don't want to have to sort through them. Okay. So
Okay.
number 16.
16 is 44,300.
Okay.
25 is 45,000.
Okay.
10 is 45,500.
Okay.
6 is 45,000. And
So we have 45,000 twice, right?
yeah, we do.
Okay.
And then 22 is 59,500.
Okay.
Final mean. Okay, what did you guys come up with a sample?
So for the mean of my sample, 47,860.
Yep, that's what I got.
Okay.
Is that what you got, Stephanie?
Hold on. I did something wrong. Okay, 47,860.
Yeah.
You said okay.
Mm-hmm. So we are, this is 47. Well, I'm in the middle of a meeting. What do you need? Do you want to say hi?
So then we say hi.
Come here, you can come say hi. He's waving. My husband.
I'm not going on there.
He's not going to say hi, huh?
He's like, hi.
Doesn't want to be.
Is that any way to greet me? And I'm like, I'm busy. What do you need? All right, so it says to draw it on the map. It says, make a mark on the horizontal axis to indicate the value of your sample mean from part A. So our sample mean kind of falls between it just shy of that 48,000 mark, right?
Mm-hmm. Right.
That's where it's not unusual.
No. And isn't that because of the central limit theorem?
Yeah.
When the sample mean is normal, then the x is normally distributed?
Yeah. The sample means. Hold on. La 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 la.
Just wait for them to get done. Okay. Let's go in our room or something. Or in your room. Come on, buddy. Sorry. It's definitely easier during the week when everybody's at school, right?
Yes.
Okay.
Now we just need your family to come on in, Carolyn.
Well, I'm trying to get them. They need to go.
Are they there?
They're there.
They're just having.
I keep texting my husband, time to go, time to go.
Oh, are they leaving somewhere?
They've got, my son has basketball pictures, so.
Oh, you're like, oh, you're ready to go.
Yeah, come on. I can't get up and yell at all of you, but it's time to go.
Let me pause the video, then we'll go over there. Okay, where are we at? Are we at, okay, are we still on B then?
We're on C. C is the sample mean appear to be unusual. It's a little high, but I don't think it's unusual. But that's because we also had that number 22 as kind of an outlier.
Yeah, the 59.
Yeah.
If you look at all the other data, I mean, granted, technically you're saying you don't have the other data, but.
Because it falls pretty much within one standard, or one, what do you call that, deviation?
Mm-hmm.
From
That 68% thing.
Yeah.
Yeah, that's what I thought too. I'm like, well, it's kind of on the edge of that, but.
Okay, so on D.
Oh, were we supposed to each do our own?
Well, I guess, because I didn't.
Well, then let's just do it again a couple times.
Okay. So I'm going to draw my.
Okay, here's 120.
Wait, where are you seeing?
Number C, it says compare your mean from 7A. So with 3 other individuals.
Oh.
So
So we got to do it. So we each need to do one, and then compare it of our own.
Okay.
okay, so each of us do our own random sample, and then do again. So you guys can come up with your numbers, or I can give you guys numbers if you want, because I got that random thing up right here.
Okay, give me 5 random things because I don't have that pulled up.
Okay, ready?
Yeah.
8, 4, 5, 26, and 21.
Okay. Thank you.
You're welcome. And then Carolyn, since you've got cut up ones, it's easy.
Yeah, I got mine.
They put the comma in the wrong place on number 5. That's funny.
Yeah.
They did.
I didn't even notice that until.
Toy. Nicholas, are you ready? It's probably in the laundry.
Did you get him going?
Well, yeah, terrible miscommunication. One can't find the jersey, and the other thinks that he doesn't want to go. So who knows if they'll make it there? If they do, they do, and if they don't, they don't. They won't be in the picture, or he won't be in the picture.
Not the end of the world, but still, Mama wants a picture, right?
Yeah.
Just go do a little bribery. Maybe that'll work, you know.
Okay, so did you guys get yours?
Okay, I got 46,440. It's a little lower.
I got 44,600.
And I got 46,320.
So you guys were both normal. You guys were definitely normal. Mine was a little low. And then the other one we came up with was a little high.
What was yours, Patty?
44,600.
44.
44,600.
And then you got 46,000, Stephanie?
Yeah, 46,440. So yours and what was yours again? 46 is right next to mine.
320. So, but they still all fall pretty much within one standard deviation from the true mean of all the 30 numbers, right?
Yeah. Yeah. So we're normal, but
One
we're
standard
still
deviation away from.
close to normal. Huh?
So the means, it's one standard deviation. So what is one standard deviation away from 46,000? Is it 47,000 or 48,000?
Well, I would say it's probably 48.
That's 5.
And then 50, and then 52 is 3 away.
Okay.
I don't think it's even asking that, but.
I'm just curious so I can understand that a little bit.
So yeah, but I think
we could probably figure it out if you guys want to figure out like the z-score and stuff and figure that out, but.
Oh, but 40,
just asking. I think they're all kind of approaching normal. The bigger the sample, of course, the closer you get, which is what it's telling us. But this is yeah. Your guys are normal. Mine is approaching normal.
Okay, so what is the shape of the distribution of the sample means from all such samples? So I think we pretty much talked about that. They're normal.
So distribution.
Check in my closet.
With a normal distribution, have a normal shape.
And comb your hair.
Carolyn, if you need to go run and help him real quick, you can. You want to go get that stuff and comb his hair? Go do it.
Well, he should be able to do it.
He should. But
Yeah. So.
that's how my
Okay.
10-year-old too. I don't know how old yours is, but my 10-year-old's like that.
Yeah. Well, my 10-year-old's a girl, and so I pretty much get to do her hair all the time. Otherwise, we just brush it and leave it down, or it's a sloppy ponytail.
Fun, right?
Yeah. She has a son's game tonight. She's doing the pre-performance. So we're going to get to do makeup and hair. She's super excited. She gets to wear makeup again. She loves performances because she gets to wear makeup.
Oh, that is fun. That's really cute.
It's pretty awesome. All right, so for number 8, it says it's normally distributed with all this other blah blah stuff. So the shape of the distribution is going to be normal because it's normally distributed.
Yeah.
Based on the rules they told us, what they told us already.
Mm-hmm.
So the shape should be normal because it's normally because the population, because they're normally distributed to begin with.
Mm-hmm.
Your population is normally distributed.
Are you on 8B? Because the parent population is normally distributed?
Yeah. Yeah.
Okay.
Is that what you guys got?
Yeah.
Mm-hmm. Yeah.
And then 8C, it tells us the sample mean is 529. And then for D.
Wait.
Oh.
Okay.
Yeah, so that'll be 529 for C. And then for D, you got to do the formula, which is theta over square root of n, which is 10. So it's 113 divided by the square root of 10, right?
Yeah.
Yeah?
Yeah. So and then I got the square root for 10 is 3.162. And that's 113, so it's 113 over 3.162.
Yeah.
Which equals 35.737.
Can you guys tell me how you did that again?
Yes, 35.737.
So the formula is for the distribution of sample mean is this standard deviation over the square root of the sample size.
Okay.
So the standard deviation is 113.
For the population.
And the sample size, it tells us, is 10.
Mm-hmm.
Okay.
Okay, so then you square root the 10.
All right, and then divide that into 113.
Yeah.
So, what did you guys get? Did you guys already say 35?
5.737.
Yeah.
35.737?
Yeah.
Mm-hmm. It's like 736.
I got 7337, so it'd be 734.
Let's see.
I got 7368.
What? What? Daddy. So 35.73.
Oh, I got it. No, I got the same thing.
Yeah, 35.737.
What did you get for your square root of 10?
3.16227766602.
Yeah, so then if you just round it to the 3 placed values out,
Oh, okay.
3.162, does that change your answer?
Yeah.
Okay.
Okay. So that's what we did this time. So do you just always just round 3 places out when you do it and then figure it out?
3 to 4 places, depending on. Well, sometimes the question says only do it to 2 place values or to 3 place values.
But it doesn't say do 3 place values here, right?
But yeah, somewhere in a previous lesson it says the standard is 3 out.
Oh, okay.
Unless they tell you otherwise, to go to 3.
Yeah.
Okay, got it.
That's okay. That's all the further I ever go. It's not because that was the rule.
Well, I just figured it
Well,
out
maybe
and then
that-
divided that by I just plugged in the whole numbers and so it automatically just does the whole thing. It doesn't do the
No.
3 place
Oh,
values.
parentheses and stuff. Yeah,
Yeah,
see,
so
I'm
I
not
did
graphic
113 divided by the square root of 10 and then I got the other number I told you. And so if we have to figure out that part first and then
Well, you're using a I'm using this one.
Me too. Me too. Right here.
Oh, so you're using parentheses then.
We thought you had a
I wasn't using.
calculator over there.
What's that?
We thought you had a scientific calculator.
Oh, no.
Where you can punch it all in and it'll do it all correctly. This one, I don't know. I didn't do it that way because I didn't use the parentheses.
So, like, if you were to do, like, on your phone, Patty, and you did 113 divided by the square root of 10, like, just plug in the formula and plug in the numbers, then you're going to get the other number I said, which then it's going to be 3.162. Oh, sorry. Whatever. I don't know.
Oh, yeah. Yeah, you're right. You do. I didn't do it that way because I always figured out with the square root you had to do that first because it won't hold. I always forget that it'll let you do it if you put the number in first.
Yeah, well, and so.
When I did it that way, I got the same number you did. I see what you're saying.
Yeah.
So
So
when we do
35,733,7.
If we do our homework like that, then what are they going to want us to do? Plug in the formula and get that answer, or get the square root first and then do 3?
The truth is, every time we've done it, we've never had something that was that close that you're talking about 1 decimal point.
Yeah. Okay.
Like if you go 3 out, that's either a 4 or a 7.
Yeah.
I've never seen the questions that close in answer.
Okay.
Does that make sense?
Yeah.
But then again, if you're putting an answer in, say to this decimal, if you're rounding it off to that decimal point, it wouldn't have mattered either way, I don't think. Yeah, it would have. It would have made it. It would have been close.
Yeah.
Whatever. Well, we got them. You guys understand how we're doing this now? You guys want to do the group meeting?
Yep. Let's do it.
The quiz. Mm-hmm.
Okay. When taking samples of n, when n equals 5, what is the shape of the distribution of means in histogram when the parent population is skewed right? Ooh, that's with that.
Oh, gosh.
Where did that go? When it's skewed right. I don't know.
That was
I'm looking at my graph and I don't remember where it's.
Isn't it?
What's that?
Isn't this last week's stuff? The
No.
And the thing is, it didn't really talk a whole lot about skewing right or left, only when it had us practice in that program.
Yeah. So that's what I'm pulling up. I'm trying to pull up that graphing thing again.
Okay, the mean is 5.
Okay. Here. So on here, so if it's skewed.
Wouldn't it be right skewed? Because if it's your distribution of means is right skewed, then
What was the question again?
it says when taking samples of n, when n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? I guess you have to do that thing
Well, here.
and get it to drop it,
Just to
right?
get it drop and give examples. I was wondering that too.
So like on this, it'll eventually build up. Over time, it'll be more. It ends up approaching normal, but
But though isn't our sample size pretty small? Our sample size is 5.
when n equals 5,
Somewhere they said when n is 30, then it's a pretty good.
yeah, when it's larger, it's going to be normal. But
I wish they
it looks
dropped
like it's still.
faster.
Well, here in my notes, I found this thing with the graph. It's got it for original population. It's it's more gradual. Hold on. Population, it's more well, and then with the sampling distribution of n equals 5, it's still right skewed, but it has a little bit different shape. And then with the sampling distribution of 15, it becomes more normal. And by 25, it's really narrow and normal.
So, but with 5, it would be right skewed.
It'd still be right skewed.
Be the right skew like the.
So, when taking samples of n over 100,
It's going to be normal. Because the higher, the more normal it's going to be. It's going to approach normal.
correct. And then number 5 would, when taking samples of n equals 100, what's the shape of the
It'd be normal.
distribution of hemes when it's normally distributed normal? Yeah.
Mm-hmm.
All right.
Oh, sorry.
Oh, that's okay. This one we can choose all correct responses. When would the distribution of means be normally distributed? So the first one is data are drawn from a population that is normally distributed and the sample size is small.
Mm-hmm.
And data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from the population that is right skewed and the sample size is small. I don't think it's that one either. Data
No.
are drawn from a population that is right skewed and the sample size is large. Ugh. The first two for sure, don't you think?
Yeah, and I think it's 3 of them. I think it's the first,
Yeah.
first, and the last, because the only one is if it's right skewed and the sample size is small, it's not going to be normal. But if the sample size, it's going to approach normal.
Yeah, because we watched that video on that too, and we just found that out on here.
Yeah,
I agree with that, yep.
Okay, so options 1, 2, and 4. Is that what you guys put?
Yeah,
Yes.
1, 2.
Are your guys' just curious? Are your guys' answers in the same order as mine?
Yeah, for that one it is, yes.
Okay.
Here's what my phone calling. Okay, find out. Yeah, sorry.
It's okay.
Okay. So yeah, I agree. 1, 2, and 4. Is that the last thing?
Yeah.
Are you guys talking too much, or did I was too long?
The only one that it's not is data drawn from the population that's right skewed and the sample size is small. That's not.
Yeah, that's the same. That's the same answer I got. Okay.
Yeah. Okay.
Great. Which of the following gives the best explanation of the central limit theorem? The simple means will follow normal distribution. Wait.
I don't think it's that one because it doesn't say, because the central limit theorem has to be a large population,
Mm-hmm.
and it doesn't say anything about the large sample size.
Okay.
The last one then. If the sample size is large, the shape of the sampling distribution of the sample mean x bar, whatever, will be approximately normal. Or
That's what I think the
well, the
last.
central limit hold on. As the sample size increases.
Oh, go ahead.
Okay, it says as the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. So that is the last one.
Mm-hmm.
All right.
Sorry, I had to read the deviation. I had to read the definition again because I've got interference at my house.
Oh.
But
Like, what is she reading from? That's not what okay.
I was like, I don't see that on there. Where did she go to a different?
No, I was looking at my notes. I was looking at. Sorry, that's why I was like, I don't even know. I'm just gonna read my definition again in my notes and then see what this says.
Exactly. Oh, I'm so tired. Sorry, guys.
Don't worry. I hear you. Okay, so let x be a random variable with population of.
Wait. On number 7, did you guys do the last one, or what did you do?
Yeah, I said the sample size is large. The shape of the sampling distribution of the sample mean x bar will be approximately normal.
That's what I thought it was too. Okay.
Okay.
Want me to read the next one?
Let x be a random variable with population. Go ahead.
Oh, go ahead. Go ahead. I'll just do the next one.
No, it's fine. I just was jumping in. Let x be a random variable with population mean mu equals 10 and population standard deviation sigma equals 6. Suppose a sample of size n equals 36 is drawn from this population. So what the distribution sample means is going to be the same. It's going to be 10, right?
I got 1. Because don't we plug the numbers into the formula?
This is sample mean. The sample mean, the population, it's the population mean and the sample mean. That's the standard deviation.
Oh, you're right. Yep.
A tricky one.
Yes.
Okay, so this is one where we plug that in. So it's 6 over the square root of 36, which would be 1.
Yeah. Okay.
Do we need to put 0.000?
I hope not. It better not mark wrong for that.
We could argue that one. If it comes back wrong, we could.
Seriously?
I'm
like, put 0.000.
You didn't know.
Put a whole bunch of zeros. It wouldn't matter. Okay. Who's got number 10?
Okay. Regardless of the distribution of the population, if the sample size is large, greater than 30, what would be the shape distribution of the sample mean? And I say be normal.
Normal. I concur.
Yeah.
And for number 10 or number 11, I say it's the law of large numbers.
Oh, wait. Okay. Oh, I don't know.
I think it's the law of large numbers because it says
If the sample size is large.
Closer to the population mean. Okay. All right. The law of large numbers. Okay.
Because this is talking about the shape. Talking about the shape. I guess it could be, I don't know, it could be either one. This is where it does get confusing. But it's going to be more accurate.
Okay.
The distribution of the population. If the sample size is large, what would be the shape distribution? I would say central limit theorem.
Yeah? Because, yeah, that actually, because it's talking about shape, so yeah. I just go with the large number. Then I realized they both talk about large number, but this one's talking about shape, and it's a theorem, and the law of large numbers isn't a theorem. I'm going to get technical on verbiage.
I'm like, well, what?
I don't know. I don't want to change that and have it be wrong, but because we're talking about the sample size being large, and on central limit theorem.
Well, but central limit theorem is talking about shape.
Yeah.
Whereas the law of large numbers is not talking about shape. It's talking about where the mean is, which does apply to the shape, but it's not necessarily
what they're asking or what they're. Okay.
specific.
So, do you guys want to change the central limit theorem?
Central limit theorem is what I switched.
Okay, so really quick, guys, on 8 and 9, so 8 you put 1 and 9 you put 1.000.
No, 8 is 10. That was a tricky.
Oh.
Because the mean of the distribution sample means. The mean is the same.
It's 10. It tells us it's 10.
That's like a trick question, kind of.
Yes. Because I first said it was 1, and Patty's like, no, no, no.
No, because in the definition it says that if the
the population
it doesn't for both normally distributed and non-normally distributed, it says that the center that says the mean of the original population is mu, then the mean of the distribution of the sample means is u, or is mu.
I did the same thing on the homework. I figured it out, and I'm like, oh, okay. Yeah.
Right, so we'll leave it. 8 is 10.
8 is 10, 9 is 1.
Okay. All right. I think we did it. Submit it.
And for 11, we said central limit theorem. That's what we're going to shoot.
That's what we're going with.
If it's wrong, I'm going to feel horrible. Okay. Are you submitting?
All right.
Yep.
We're all on the same page. I'm submitting.
Okay, here we go. Yay! We did it!
We did it.
Good job. Save this from being wrong.
Good. Okay, we did it.
All right, so
These meetings are getting faster.
they are, and I think, like I said, some of the material is easier than others, so it's not as bad.
Yeah.
Okay.
It seems like the first lesson of the week is easier.
We're doing,
Yeah, that's true, Carolyn.
yeah, a lot of times. So Tuesday, what time did we say Tuesday? Tuesday is going to be.
I think I have to look at my text. I think it was like 10:30 or something.
Yeah.
10:30 or 10:30. Mountain time, right?
10:30 Mountain Time.
Yeah, because I
10:30
work
Mountain Time?
Monday night, so I may be home by 9, but 9:30 is safer to say.
Okay, that's okay.
All night and then
Going back
homework. Carolyn,
What?
you're going to be up all night and then have to come home and do a meeting?
Yeah. But you know, I can't, because I work nights, I can't make everybody else's life miserable. You know, I just have to. So every other week.
If it's easier, sometimes we can meet later in the evening, you know, once kids are in bed a little bit. Teenagers are still awake, of course, but anyways, you can stop recording. Sorry.
Oh, sorry, let me do that.